Hello team, today's challenge is zoning regulations, where we're given a two-dimensional array that looks like this, and we need to figure out if these letters are allowed to be next to each other according to this table. So in the case of, say, residential cannot be next to industrial or commercial buildings, right? So there are some rules where certain buildings can't be next to other types of buildings or other types of property in the case of, say, agricultural, right? Farmland. So we need to figure all of that out, which means that we're going to need a couple tools, not tools, but lookups. And so what I've done is right here, I've put that together. So I've gone and made a new map with our letters and the array of items that are not allowed to be next to them, right? So this is our zone lookup. And then I did our directions, right? So the things that are adjacent, and this is the math. So if we are in the middle, then -1, 0 is directly above us, whereas 1, 0 is directly below us in terms of the array. And I really like this idea of writing it like this. Even though it's a lot of extra spaces, this helps me visualize it instead of having all of this, say, just over here somewhere, if I had hit that properly. There it is, right? All in line doesn't mean anything, but when it is shaped like this, that really helps me and hopefully helps you too, okay? So with these two tools in place, we can go down here and start creating stuff. The first is going to be that violations, okay? So right here, it's going to be violations. Excellent. And that is actually what we're going to return. That's going to go down here. What are we returning? Well, it's going to be some kind of array, okay? So with that in mind, we need some loops. And for this one, we need a few, unfortunately, because of how the matrix kind of works, right? The grid. So inside of here, I go let I equal 0 and I is less than grid.length and I plus plus, okay? Which leads to the question, for this example, is I the best letter for this, right? We could use any letter or any variable name, in fact. So I think for this, what I'd like to do is change this to R to remind myself that it is row, right? That's what the first loop is operating on. It's operating on the rows. From there, I'm going to do that same thing again, but I'm going to change these to C's. And unfortunately, my multi-select would pick up on this R, so I need to kind of do it twice like this, but there we go, and we need to close it off, okay? Grid.length, the inner grid.length is not grid.length, it is grid0.length, assuming that they are all the same length. Or, if it helps, grid row.length. It doesn't really matter here, okay? So we're getting the length of the current row that we're in, and we are going to operate on that, okay? Now, inside of here, we are going to start building some stuff out. And in fact, we are going to do this a couple times. We're going to use this little bit of information several times. So I'm going to go and grab it. It is going to be grid, not like that, grid R and C, okay? So whatever the current letter is at grid RC, we grab that, we drop it in the zone, and we start doing stuff. The first thing is an if statement, okay? Because if it's not even in our zone lookup, do we need to go any further, right? And this is how we get around the empty strings, right? The empty strings, and if they threw in a different label like V for whatever silly reason, right? So if they threw something in that we don't know, well, then we're just going to exit. We're going to assume that it's okay until you give us an updated zone lookup, okay? So with that, we go if not zone lookup like this, dot has, right? Because the map, we have access to has, and we send in zone. Well, if it's not in there, right? If zone is not in zone lookup, then we should just continue to whatever that next value is, okay? That tells us that whatever this place is, we don't care. So we're going to continue the next current loop. It doesn't go to the outside loop. It just goes to the next, whatever the current loop is. Okay. So that takes care of that, which means that now we can reach in. If we get past this, we have it. We have something that is up here, so we better get those values. Let's call it forbidden. These are the forbidden ones, and that is going to be whatever that is. So zone lookup dot get this time on zone. Okay. And finally, our final loop. Okay, so for let something of what? Well, it's going to be finally this neighbor directions, right? So we're going to iterate over these 4 values to get something new. Okay, so not violations. I thought I copied that. Let's try it again. There, for let the direction of row and the direction of column, we're going to peel those off and use them. Okay. The first thing that we're going to do is we're going to get that neighbor value. Okay. So neighbor, just like this, it's going to be equal to that zone, which is the row plus the direction, right? And if it is minus, a plus minus value is the same as just subtracting that absolute value. So whatever the row is, if the row was, say, 0, right? Well, plus minus 1 is the same as 0 minus 1. No problems, okay? This absolutely works. We do the same thing here. So we have the column. We go plus DC like this. And in theory, we would be okay. There is a chance, though, that these plus and minuses might take us outside of the grid, at which point we would get undefined values. So we better protect against that, right? If this comes back as undefined, then we should just return an empty string. Not a problem, right? Because we can test against empty strings. They're never going to be in anything that we're testing against, so it should just pass through as clean, okay? There's also the chance that the row might not exist, right? If we're going up or down, then the row might not exist. And if this is undefined, then the column will throw an error as this value doesn't exist on undefined. That's what we'll return. So right here we use optional chaining, which is a question mark dot to get it done. So optional chaining plus this bad boy here, which is nullish coalescing, I almost forgot the term, gives us exactly what we need. Regardless of anything, we will get an empty string if it returns any sort of undefined, which is great, okay? So now we just need to test it. So if forbidden dot includes what? Well, neighbor, right? Neighbor. My fingers don't want to type that one, but that's okay. We got it. If forbidden is included, or sorry, if neighbor is included in forbidden, that's the way that we're going today, then we should add it to violations, okay? So violations, just like this, violations dot push. And what are we pushing? Well, it's an array of row and column, okay? And because we found one, we don't need to go any further, right? We don't need to see if there are other values that are in violation. This spot is already in violation of something. So we just return it, which means that we can save ourselves a little time by breaking, at which point everything should work. And it doesn't. Why doesn't it? I probably missed a step, which is just super, isn't it? Neighbor dirs zone. Oh, this should be grid. Oh, yeah. Silly. Okay. So anyway, naming things, right? Naming things is hard, but I totally named that wrong. It should be grid. I don't know what I was thinking with trying to get values off of zone. That's so weird. But here we are, okay? And it works. So to recap, we got our data. And today I used a map, okay? Could you have used an object in here? Yes. Is it faster or slower? That I don't know. When I tested this, they were pretty close. Map won by just the smallest amount, right? Which is why I'm using it today. But you could use an object here. No problem, okay? It would change some of the things down here, like the has and the get, but we can figure that out, right? That's just code. And then, of course, our neighbor directions to help us do this. And the great thing about this is that if they went and added a new value here that was say we wanted the corners, right? So that would be -1, -1. Well, as soon as I do that, it's in the system. I don't need to do anything magical. My code should just run and it will test that corner and be done with it, okay? So this visual really helps me to sort all of that out, right? Bringing it back. And if I need to update it, well, then that works too, okay? From there, we went into our loops, and we need at least 2 because we're doing matrices. We need 1 for the row and 1 for the columns. And then we added a third because we want to be able to loop over our neighbor directions, okay? At which point we did it, right? If we get all the way into this, then we push on to violations, which is the thing that we return, and it works. So there it is. Again, not every solution, just hopefully one good solution. And I'm okay with this. Even though it has 3 loops in it, I'm okay with how these loops do individual pieces. Maybe you're not. Maybe you hate it. Maybe you did something else. Let me know all that good stuff in the comments. Otherwise, today this has been zoning regulations, and I will see you in the next one.